I'm Chuck Wisman from Megger. I'm going to demonstrate the HT1000 in bringing up a triple play circuit with video, voice, and data. For your convenience, we have an auto test that will automatically run a series of tests. There are 8 scripts that can run each of these seven standard tests: volts, current, stress, ohms, open, or coils. So as an example, for the script 1, I can enable stress test and open meter, and once I'm done, I save and exit. If I choose that script, it will run those tests I have selected. Okay, so now I'm going to hit the 9 key for our auto test. I can choose a number of 8 different scripts by pressing any of the number keys here. So I'm going to choose script 7. Okay. Once I've chosen the script, I can hit start and it'll launch the test. So first it runs AC volts, AC and DC volts. Now it's run loop current, stress test, ohms, and it's going to run it both tip ring, tip ground, and ring ground. Once it's settling. Now we're on the open meter, and we're getting about 870 feet tip to ring, 840 feet tip to ground, 155 ring to ground. Now we're running a load coil, 0 coils. At the end of the test, it automatically stores the results and gives it a time date stamp. Okay. For even greater convenience, the unit, by selecting the pass-fail, it will make a determination of the parameters if they pass or fail the program thresholds. So I'll hit the start key. So it's checking AC, DC volts, all those pass. Loop current, stress, it's giving that a marginal reading. Ohms is marginal tip to ring. Tip ground is pass. Comes ring ground is settling. Ring ground is pass. So open meter, there's no pass-fail criteria on that. It is what it is. So 840 feet tip ground, 844 ring ground. See open meter, or load coils. Now we got 0 load coils, and at the end it also stores the results and gives a time date stamp. Okay, we've verified the clean line. At the D-slam, we've connected up the line to a VDSL modem. So now we're at the other end near the customer premise, and we want to check that we can actually sync up with the D-slam. So I'm going to go to the second menu. I'm going to go to DSL, and the modem's going to be booting up. The internal modem in the HT1000 is going to boot up. It takes about 60 seconds or so for it to do so. If you don't have a D-slam on the other end, you can use another HT1000 configured as a CO to emulate the D-slam. So okay, it's booted and it's ready to link. Okay, the modems are now negotiating. It's going into a handshake mode. So right now the modems are figuring out which standards they should link to. They've chosen the VDSL 2 standard. They've linked up, and this is the link statistics. If we look at our actual data rate and our attainable data rate, they're about the same, and they're 122 megabits per second, which is pretty fast. We're actually on a very clean, very short line, so getting very good connect rate. Signal to noise ratio is 6 dB or 5.9 dB, which is set by the CO. Line attenuation is only 7 dB. Signal attenuation is only 4 dB. Again, a very short line. We pretty much have no errors. The transmit power is 11 dBm. This is all on the downstream, which is more critical than the upstream. Alright, if we did have problems on this line, it's very clean, very fast. If you had problems had a slow connect rate, we could use the bins graph information. It'll give an idea of what spectrum the modems have negotiated to use. There's a lot of bins because the VDSL uses a large bandwidth. As you can see, that the signal noise ratio is very flat. It's very good. With the bits per bin, it's basically using all of them. If we had a problem with the line, there'd typically be dips in there, like if there was a bridge tap, there'd be a large gap in the center of the spectrum. Again, in this case, because it's such a clean line, the band it's using basically all the bandwidth effectively. With that, we've basically turned up a VDS or a triple play circuit. We verified that the line is clean and checked the connect rate. Customer's ready to be put into service.